Okay, let's do circular motion, and this is when cars are going around an unbanked curve, or basically they're turning around on a flat road. And what we want to do is decide if the road's got a coefficient of friction, if at a certain radius and a certain speed, are the cars going to skid out of control, or are they going to be able to continue driving around in that circle? So let's get some information here. Let's say that we have a 1,000-kilogram vehicle. It's pretty small. Radius of the turn is going to be 50 meters, and your velocity would be 50 kilometers an hour. And we want to know, will it skid if our coefficient of friction is 0.6, which is going to be dry road, or 0.25, which is an icy road. Okay, so that's our information without actually writing out a question. First thing I'm going to do is I'm going to draw myself out a vehicle here. So there's the headlights, there's the tires, there's the windshield, there's a person, hand out the window, waving at you, hello, and good enough. The person is going to be turning in a circle, which means they're going to have centripetal force that way, and there'll be a force of friction opposing that way. You'll also have a force due to gravity pulling down and a normal force opposing that because of the surface. Okay, so what we're going to do is we're going to figure out if this thing is going to skid or not at these two coefficients of friction. So let's see. First, I'm going to find my FC. So FC equals mv squared over r. So FC is going to be 1,000. I need to convert 50 kilometers an hour to meters per second. So you're going to divide by 3.6. So where will I do that? I'll do that right here. 50 kilometers an hour divided by 3.6. That's going to give me 14 meters per second. So 14 squared, and my radius is 50 meters. There. So my FC is 3,920 newtons. And I guess, since in my picture it's to the left, I'll say it's left here. Now what we have to do is decide, when's this going to skid? Well, it's going to skid if your FC is going to end up being greater than your FF, because that means it'll actually skid out of control. It'll overcome this resistance force. So that's what we're going to look for. Let's do, so for second, we're going to find our force of friction and make the decision as to whether or not we've actually got enough frictional force to hold the 3,920 newtons worth of FC. So let's do dry first. So dry, FF equals mu Fn. So my force of friction on dry is going to be 0.6 times my force due to gravity, which is going to be 1,000 times 10. So that force of friction ends up being 6,000 newtons, and that's right. So this won't skid. Friction can hold, 6,000 can hold back 3,920, no problems. Let's check for the wet. Wet force of friction is 0.25. Mass, gravity. Okay, well I can tell right away that's going to be 2,500 newtons. 2,500 newtons is not enough to hold back 3,920, so for the wet it skids, which makes logical sense, right? Concrete is a lot stickier to car tires when it is dry as opposed to wet concrete. What about, though, if I would have asked you just to find the minimum velocity? Minimum velocity to take the curve. Okay, so now what I want you to do is I want you to take that curve at a minimum velocity without spinning. To do that, what you want is you want this 3920 to equal your force of friction. So really you want FC to equal FF. So let's actually write that out. FC equals FF. Now FC is mv squared over r. FF is mu Fn. So that's mv squared over r equals mu mass times gravity. This mass cancels out that mass, so that's going to leave me up here with v squared over r equals mu times gravity. Cross multiply, v squared equals mu rg. So v equals the square root of mu rg. There. That's your minimum velocity. That's the minimum velocity to go around a flat curve before you start to spin. And you'll notice that that's the same critical velocity for a vertical circle, but you don't have any coefficient of friction. So exactly the same formula with just a little extra mu value in there. So for this above question, if you wanted to figure out the minimum velocity for either of these situations, in dry, what's your minimum velocity? Well, for dry, check it out. Your V min is going to end up equaling 17.3 meters per second. And for wet, the V min ends up being equal to 11.1 meters per second. Okay, so try it. There you go.